Welcome. So in this video I'm going to be discussing the derivative of certain trig functions that aren't sine and cosine, specifically tangent of x, cotangent of x, secant of x, and cosecant of x. So each one of these derivatives are found using trig identities. So they're not really covered on the basic rule of I just realized I misspelled secant here. My bad. So they're not covered under like basic rules of derivatives because they can be kind of found using sine and cosine and quotient rule actually. Because if we look at tangent of x, for example, we'll start with that. You know, the tangent x, according to its trig identity, is the same thing as sine of x divided by cosine of x. Right? So if we wanted to find the derivative of tangent of x, that would equal the derivative of sine of x minus, or divided by cosine of x. And to find that derivative, we would use chain rule. I meant quotient rule. We would use the quotient rule for that. So it would be low d high. So cosine times cosine, right? Because the derivative of sine, that d high, would be cosine, minus high sine times negative sine, right? And that all over b cosine square of x, right? That's just like notation for cosine x squared. They usually write that exponent with that trig function just for simplicity. So let's simplify this numerator. So we have cosine squared of x, and then these negatives cancel out, so we're adding sine squared of x. Now if you're good with your trig identities, you actually be able to realize that cosine squared of x and sine squared of x equals 1. So this top ends up equaling 1. And what we're left with is 1 over cosine squared of x, or the inverse of cosine of x squared. And that's equal to secant squared of x. So the derivative of tangent x equals secant squared of x. So now next, it's a very similar process. We will be taking the derivative of cotangent of x, or the inverse of tangent. So cotangent, so taking the derivative of cotangent. I needed x, not c there. cotangent of x. Well, that is equal to the derivative of cosine over sine of x, right? Because it's the inverse of tangent. So again, we approach this with quotient rule. So we start with low, d high. So we have sine of x times the derivative of the top, which is negative sine of x. Almost wrote negative cosine there. That would not be correct. So we have sine of x times negative sine of x minus high d low. So that's cosine of x minus, or sorry, just multiplied cosine of x. And that's all over sine squared of x, right? Because it's low d high minus high d low for low squared. So what we're left with, after we simplify, is negative sine squared of x minus cosine squared of x over sine squared of x. Now, if you see, we have two negatives on top, so we can actually factor out -1 to be left with sine squared of x plus cosine squared of x. And that equals 1, right? If you go through trig identities, sine squared of x plus cosine squared of x is 1. I believe that's called Pythagorean some kind of identity. I'm not really sure with the names. So we're left with -1 or a sine of sine squared of x, or the negative of the inverse of sine of x squared. So that equals negative cosecant squared of x. So the derivative of cotangent x equals negative cosecant squared of x. So those were the kind of tangent functions, right? Those tangent related functions. But now let's move on to the secant and cosecant functions. So we will start with secant. Secant, as we know, is the inverse of cosine, right? So if we're taking the derivative of secant of x, that's equal to the derivative of 1 over cosine x. So again, we can approach this using quotient rule. So we have low d high, which according to constant rule is 0. So this first term is actually knocked out. So you have low d high minus high d low. And that's all over low squared. So after simplification, this is knocked out. We actually have these negatives that cancel out. So we're left with sine x over cosine squared of x. And to simplify this further, what we're actually going to do is we're actually going to break apart that cosine of x into two different factors. So we're actually going to take sine of x, cosine of x, and we'll have this multiplied by 1 over cosine of x. So you see we kind of broke this cosine of x into two different pieces and multiplied. So according to our trig identities, that is then equal to tangent of x times secant of x. So the derivative of secant x is actually equal to tangent x secant x. Now if we bring this down to cosecant of x, we'll actually find a very similar answer. So we know cosecant, by definition, is the inverse of sine of x. So the derivative of cosecant of x is the derivative of 1 over sine of x. And then again, we approach this using quotient rule. So I'll say, take low, d high, and that first term is knocked out, right? So we basically have 0. I'll just say we have 0. That's low, d high right there. Because the derivative of the top function is 0. And then we subtract high, which is just 1, times d low, which is cosine of x, right? So kind of just expediting this differentiation process. And then we divide by sine squared of x. And then again, we break it apart. So we have sine x there. We multiply 1 over sine x. And then we apply our trig identities, and what we're left with is negative cosine over sine is cotangent, and 1 over sine is cosecant. So then we know that the derivative of cosecant of x is negative cotangent of x times cosecant of x. Allow me to fix that x right there. It's kind of melting into the C, making it confusing to read. So there we go. These are very specific cases, but they're also used very commonly. So if these end up being a bit too much to remember, I would just kind of try and memorize the kind of setup and process of differentiating these functions, so you don't necessarily have to remember them. But I feel like in time, it'll just come naturally to memory. So thank you for watching. Keep studying, keep learning, keep practicing.